So I have started with putting together a list of some FAQs that have come in through some of our territory managers and some of the questions we've received through the support team, and just look at some examples of data for any of those that were on last month's call. Please feel free to enter into the chat and enter a question there, or we can also unmute. And if you have examples that we could look at, we'd gladly accept those examples to show everybody, because I think one of the most important aspects of this is kind of learning from all of our different experiences. So one of the first things here we talked a little bit about last month, but I want to reiterate on is what is a root zone and how is that determined. So let me get my screen shared here. Okay, got the screen okay? Cool. So when looking at what is a root zone, I mean, there's a little bit of a two-part question to that. And one is figuring out how deep our roots are and where they're active at, where they're pulling the most water from. And then the second part of that question is, if we were going to utilize the root zone sum graph feature, how do we set that up and what's the strategy behind that? So for the first part of the question, how do you determine how deep the roots are active and where is the majority of the water pulling from? That's where you would view your individual moisture graph, and there's two ways to view that. There is a graph here where you see all of the depths on the same y-axis, and that's just fancy terminology for we're seeing them all in the same graph. The other way to see it is in a stacked version where they're actually all kind of graphing on their own, which means kind of how big or how many pixels you're seeing here on this graph is determined by how wide of a range of values are occurring within that. And that helps us view the data in two different ways that it's really useful depending on what you're looking for. So if we really wanted to see where the majority of our water is coming from, it's really easy to see the majority of our water is coming from our top sensor. So the wide ranging values in this blue line are occurring at the 4-inch sensors. In this case, we're using one of the new V4 sensors with the offset feature. And the next sensor down, the 12-inch sensor, is where we're seeing our second most water come from. And again, that's what you would expect because crop water use is going to occur from the top down. And then we are seeing some water use even at the 22-inch sensor. Then when it comes to evaluating how deep your roots are active, that's when it is a little bit easier to see the root activity occurring on the stacked version of the graph. And the reason that that's easier is because if you have our 4-inch sensor here, for example, that's ranging 20–25% over the course of 3 to 4 days, it's a little bit harder to see what's going on at the 22-inch sensor, but when it kind of gets on its own graph here, it's a little bit easier to see. And so you can tell that the days that we have gone the longest without any water applied to the field. So if you look here on July 5th and July 7th, we received an irrigation or a rainfall. Once we got about 3 or 4 days from that point, that's when we started to see our deepest root activity start to occur again. And that's because the crop's going to use the water from the top down. It's going to use the easiest accessible water and then move on down to further in the profile. So it makes sense that when we were at our driest point is when we were just starting to see some root activity occur again at 22 inches deep. So a couple different ways to see the data at the individual sensors, as well as answer the question of how deep are my roots and where is the majority of my water coming from. And let's say that you had a dry early season and a very wet late season. You might see root activity develop early, deeper in the profile, but if it stays wet in the second half of the season, the majority of your water in the second half of the season is going to come from the top sensors because it doesn't need to use water from the deep sensors. So it's entirely possible that you would see deep root activity at one point and then later on it might go away. The second portion of the question regarding root zone is when to use the root zone sum. And I don't think that's needed unless you have a crop that has a very limited root canopy. So if you're working in a crop that has shallow roots, and if those roots are significantly shallower than the deepest sensor you have. So we have different versions of sensors out there, especially with sensors that have a bottom as far as 36 inches deep. It might not make sense to include the moisture at 36 inches in your sum graph if you're working with a crop that only has 12-inch roots. So that's where you could utilize this root zone sum to make all of your CropX insights and your soil water status bar function off of this. So in order to set this up, we would determine where our root depth is. So for example, if I chose 12, we kind of have to do a little bit of trial and error in order to set our full and refill point. So I'm just going to pick a number here, about 4, and set our refill at 50%. And again, I was just picking numbers in order for me to be able to see the data when only looking at a 12-inch root depth. We're sort of close. I'd probably lower the refill line a little bit. And again, you could either set a new one or you can always edit existing set points in the history tab. So I'd choose another 12-inch root depth. I'm going to stick with 4 and set it at 40%. And that number is going to be low because when you're working with a profile that's very short, generally you're going to have to be a little bit more aggressive on that refill point percentage. So that's when you would use the root zone sum and how to set it up. Next topic we were going to look at was just where to set refill points. And there's a couple different strategies I use when determining where to set a refill point at. In the early part of the season, one of the ways is just the same exact way that the auto set points work, which is kind of starting with a default. But to go beyond that, another way to look at that is if you're familiar with the irrigation practices in your area, or maybe how aggressive a grower might be in his irrigation strategies in general, that can kind of give you an idea. So for me, what that looks like is a lot of times growers are going to use anywhere from 0.7 to 1.1 inches as the rate that they're applying with their irrigation. Okay, so let's say we're just working with an inch. Well, and I'm also in a climate where we generally should expect rainfall to occur. So if I have an inch of water going on the field with my pivot, and I do always have at least a chance of rain occurring, and I have soils that we really do have good available water, we have a lot of water holding capacity, then it's pretty easy to have that optimal zone be at least 2 inches wide. So the distance between our full and our refill point. So if our refill point is our trigger for irrigation, and we set our refill point 2 inches below our full point, at any given moment, even after an irrigation, we're at least going to have an additional inch of available holding capacity in our soils. And that's good because you're going to mitigate the risk of having an overwatering event, right? So as long as you've always got extra room for water in the profile, you've got a good air to water ratio. You're not oversaturating it. So that is one way to look at that, is how many inches below full am I willing to go to set to trigger my new irrigation. So that's one way to look at it. Another way to look at it is watching the rooting depth and the patterns that we see within the stepping. And what I mean by that is, if we know that the plants use water from top to bottom, like we talked about earlier, then the moment or the time when we see this slope, especially of the top sensor, start to decrease. In other words, if the next, here's the angle of this line currently at 4 inches, our 4-inch sensor. If we didn't receive this irrigation a few days ago, and this line continued, eventually it would start to flatten out, right? Eventually our water is going to run out at that depth. The point at which that slope starts to decline is indicating the point at which we're getting down to maybe a wilting point at that specific sensor depth. And see, we're also seeing a pattern where the water use at the lower sensor is accelerating deeper the drier this top sensor gets. So all of those things are indications that, hey, maybe it's time to refill. I want to encourage root depth deeper in the profile and utilizing some of that that water. So hey, maybe the point at which whatever moisture level I was at this time before this irrigation, maybe that is a good refill point. And that is why you see I moved it lower in this example. So I think in this case, I was being very conservative this season setting these points because we were going into a season where we had very little subsoil moisture. Now that we're in the middle of July, we can be a little bit more comfortable. Yes, it is. We're at the peak of our hump now, and the rain forecasts have changed a little bit. It's a little bit more favorable, and we can see that our crop is doing just fine down at this moisture level. So that's another way to look at it: is at what point is my rooting depth starting to push itself into the deeper levels? Because that's really a good indication of a healthy plant. Okay, one of the other questions we've been receiving is when to use the offset feature. And just a refresher, the offset feature is the ability for you to not install any CropX sensor all the way into the ground. In other words, if you would like to utilize a different sensor depth configuration, you can do that. And what that means is if you would typically have an 8-inch sensor as your top sensor, you could leave that out of the ground 4 inches and choose to have that first sensor at 4 inches. So that's something that's determined at the time of install on the install registration process. And some of the main questions we've been seeing is when to use that. For me, that is something I would utilize all of the time. I think it's advantageous to monitor the depth between 4 and 6 inches compared to 8. We receive a lot of inquiries typically in a season about why somebody might not be seeing infiltration from their irrigation. And a lot of times it's because they might only be putting 60 hundredths on and their first sensor is 8 inches deep. Well, in a lot of soils, 60 hundredths isn't going to infiltrate 8 inches deep. And so this is one way to mitigate around that. One example of a place where it has not made sense to utilize the offset feature has been in our wine grape customers. That we're definitely sticking with the full depth option. So, I mean, and it's up to you as the dealer or the customer to determine what might be right for you, but there's a lot of agronomic reasons why it makes sense to move that sensor up in the profile. Okay, on to kind of back to that report card check. And I want to talk about 3 different examples and how to think more longer term or more at like a 30,000 foot view when it comes to looking at the sensor data. And what I mean by that is most of us by now have weeks, if not a month and a half or 2 months of data at this point. And what we can do with that is figure out, well, have we been trending upward, flat, or downward in our overall change compared to the beginning of the season? And so to start, here's an example of one where we really have trended downward. And this is that example where we actually moved the refill point lower. And so I think it's okay in this case. There is not a problem with that. But when we have a sensor that's clearly working just fine in terms of its functionality. When you can draw a line between your first week and your last week, and it goes like this, we can be extremely confident in this case that we have less moisture in the profile now than we did a month and a half ago or 2 months ago. There's really no way to dispute that.
Nick, if I could stop you for a minute, can you
Sure.
check the waiting room? I've received a message from a few people who are in there.
Okay. Okay, should be all set. Okay, so in this case, again, we're looking at a trendward or trend that is downward. And again, I don't think there's a problem with being in the situation. I think we have a system that is going to keep up from here on out. But that's one example. Gotta switch from my drawing tools back to my mouse here. Okay. In this example, I'd say this is one where the trend is flat. In other words, we really don't have a big change from the beginning of the season to the middle of the season now. You could pretty well say that that's the trend that we're on. And that's okay. I mean, considering how dry we were, I know we were at the beginning of the season. This was kind of our goal going into this year, was let's just make sure and maintain our moisture through, especially through these reproductive stages. And then in this example, we've got an upward trend. So we received significant enough rainfall right at about the first of the month and after the first of the month that we have increased our overall moisture. Not a lot, but we have increased quite a bit. You can see the full point was being adjusted by the auto set points throughout the last couple of weeks, and then I kind of set a manual line to kind of determine where we're going to be for the rest of the season. And so this one was really caused by rainfall. These are some late planted soybeans, so not a lot of water use going on yet. But here's another example where I'll flip it back to this profile some first. And this is where we have another upward trend. So we can feel really good about where we are at this moment of the season, especially compared to where we were. And the funny thing is that this field is essentially across the road from this one. They have been helped out a little bit by rain, But what I think this goes to show you is that you can't necessarily just irrigate based on, proximity. Let's just pretend we had a sensor only in this field. Well, we'd probably be over irrigating this field even more. So again, these were helped out a little bit by rain, but I think we've kept up so well with this irrigation that we really could leave it off for a little while. Hopefully the next 5 days of this field would look something like this. We might go 3 or 4 days extra beyond where we were at this point, irrigate, and then go another 3 or 4 days. So then we end up about flat with where we were at the beginning of the season, which is where I've got my refill point set. And then once we come back down here, then we can kind of go back into maintenance mode and have that flat trend. So this is one of the few examples, at least this year in my region, where we do have an upward trend that hasn't been helped out by some rain. Okay, just a little bit of generic discussion that was one of the bullet points here, was just talking about the reproductive stages of the row crops that we're primarily working in. I know that we're getting into more and more diverse crops that are out there. So I guess plug your ears for this. But so for our corn and soybean customers, this is obviously the time for the most part where the majority of the country is in the tasseling for the corn. That's your reproductive time. And, it's the time where you want to make sure that the water is there for the crop. I've got an example next where we're actually looking at a field that's on allocation that we're kind of starting to get a little short on. And so we'll talk about the strategy, especially since we're in the middle of tasseling now. For the soybeans, the most critical stage is typically 2 to 3 weeks away still. So after the flowering event and they start to, set those pods, that's an important stage for those soybean plants. So, for some people that might mean being a little more conservative on that refill point during that stage, during a 2 to 3 week period of that critical stage for either the corn or the soybeans. For me, I generally just keep my refill lines flat, and then towards the end of the season, lower them. So let's look at that example where, in this case, so we have a field here where the grower is on an allocation. And what that means is that they only have a certain amount of water that they're even allowed to pump in a given year. In this example, I believe he said it was 12 inches. We've currently already gone through 6. So that only leaves us 6 inches for the next 8 weeks or so. Given that it is that critical moment and that critical stage, we don't want to be too aggressive on letting it dry out. But my suggestion at this point was we need to go an extra day or 2 in between our irrigation events. In other words, we're going to see a downward trend like we did on that first example over the course of the next 6 weeks. We have to even make it that long, unless we end up getting a rain. It kind of just buys us more time to hopefully get some help with rainfall. So what that looks like is, again, over the next 5 days, hopefully this sensor is going to look like this. So here's the point at which we would probably normally irrigate, right? We're kind of flat with our previous irrigation. I want to push it an extra day or two. So let's push it here and then irrigate. And repeat that process over again. And yeah, we're going to trend downward because 5 to 6 days after that, we're going to end up down here, and then we're going to irrigate, and then we're going to end up down here, and then we're going to irrigate. So that downward trend is going to occur based on our current situation with this allocation. I think that's the best way to stretch what moisture we have. And that keeps that top foot active, that keeps the majority of your nutrients being pulled in at that top foot active every 5 days, basically. Once we get to the grain fill stage, it makes it a little easier to maybe go an extra day, so maybe another 3 days after our last irrigation level. Okay, one other thing we've had is kind of a lot of questions around, well, is my data working properly? Is my sensor working properly? A lot of times when you have questions about your data, it's pretty easy to try and blame technology. If your sensor is, in general, reading what makes any sort of sense at all, in other words, 100% VWC is not possible in a soil. So if it said that, then that's wrong. But if it's saying something that's remotely possible, you can generally bank on the fact that it should be working, and that it's not, if it's showing patterns that exhibit some sort of crop behavior like this, that makes sense. If there's a lot of things that look like a kindergartner scribbling on a page, then that might be cause for concern. So the example I have is, let me see if I can pull it back up here on my other browser. Okay. So here's a recent example where the install occurred, and just a few days after install, we're seeing some pretty low volumetric water content values. This is in the 7 to 9% range at both our 8 and 18-inch sensor. This is a medium to heavy soil, so we would expect our values to be much higher than that, probably in the range of 25% plus. And what I think you can see here is the use of quite a bit of water at the time of install. I don't know in this situation if that was necessary. So in general, it's good to use just the minimal needed in order to get the sensor in the ground properly. I think in this case, we might have some poor soil contact, which is why we're seeing some low values to begin with. But one thing I wanted to encourage is, when you receive, or when you install a sensor, you receive a message that tells you what those volumetric water content values are at the time of install. So in this case, you're going to see a message that looks just like this. And you should just do a little bit of a sanity check when you receive that message and make sure that what the sensor is reading in general kind of makes sense with what you observed at the time of install. So that's a way to be a little bit proactive and preventative on any issues that you may notice down the road. In this case, we're several weeks past the time of install. Haven't gotten a lot of good information from it up to this point. Another common thing we've received is, hey, I've got a sensor and it's not showing my irrigations. So here's an example of one of those where, according to their observation, or according to the way that they were irrigating, they thought that they should have seen more infiltration. And so the questions to ask at that point are, what was applied with the system, and make sure that what they think was applied was truly what was applied, and checking the location of the sensor. If it was in an area that isn't representative of the field. I had an example a year or two ago where the sensor had been installed in an old fence row. And so it was a very different environment compared to the rest of the field. It was very compacted. That's just one example of what can happen. There's a lot of other reasons why a soil might be pretty compacted, but that's another reason where you would see limited infiltration and therefore, not seeing your irrigations show up very well. And another reason is, if you are applying what you say you're applying, if that amount is a fairly small amount, and if your sensor is at 8 inches, kind of like what we talked about earlier, the majority of that water is going to be soaked up by that top 6 inches, and not very much of it's going to be infiltrating to 8. If you have that going on, though, I mean, what we can still be confident of, though, is, regardless of what is going on at 4 or 6 inches, so maybe we aren't seeing an inch, maybe we don't see this thing go up an inch every time we irrigate an inch. That's fine. We don't necessarily need to know that. But what's important is what is happening at 8 inches. Am I trending downward? Am I trending flat or upward? That's still going to tell us what we need to know in order to plan our future irrigations. If we're trending downward, we better irrigate more, depending on what the time of the crop is and what's going to happen in the next couple of weeks. If we're trending upward, we better stop the pivot and maybe let that 3 or 4 days of rooting activity occur at that 8-inch sensor again. So those are the examples I wanted to go through. Anything that anybody live on here wants to take a look at?
Wasn't really a question here, but looks like we had an interesting observation here that the wildfire smoke was hindering some of the usage of moisture by plants earlier in the season when that was over Michigan.
Yeah, I do remember. Yeah, I think it was 2021. We had the same here from, I don't know, the Rockies, I think. Yeah, it definitely made a difference. I see another question about on a V2, your stacked graph is going to show some interpolated values on the individual sensor graph. So Jason, that question was from you. So you have a sensor that's 8 and 18. Why is it showing all these other ones? That was a feature that we turned on a couple years ago in order to help out with some of the hesitations with only having 2 sensors in the ground. We were doing some interpolated versions of that. I haven't really heard a lot of feedback, yay or nay on that. I guess I'm a little bit blind to it. I really don't pay attention to it. So you know which ones are real and which ones are the interpolated ones. So I'm not sure if that's a feature that we can turn off specific for a specific sensor as a support request or not. But if you have general feedback about whether that's a helpful feature or not, that's something we could possibly change in the future. Okay, Brian, I'm looking at your question in regards to the root zone summary. The full differs between the 2 probes by 2 inches. Yeah, that makes total sense because in the case, so he's got a V4 and a Syntec in the same field. I think what you're asking is, why is my full point so different from one to the other? Well, it's because one of them is longer than the other, and therefore including more soil in its calculation. So if I asked you how much water is in your soil in 36 inches, and then I asked you how much water is in your soil in 26 inches, well, there ought to be less water in 26 inches than 36 inches, right? So you're always going to see more water the more soil you're looking at. Did that help, Brian? Or you can unmute if you need to, or maybe I misread it.
Yeah. Thanks. So yeah. So just thinking about that. So that's looking at plant available water then across those. So to reiterate that to you, we had an extra 2+ inches then between 26 and then 34 inches. Then is what that would kind of tell me, right?
Yeah, I mean, so let's say your profile sum on your V4 was 9, whatever. It's showing 9 right now, and your Syntec was showing 11. Yeah, I mean, there's just more water in 36 inches than 26.
So how does that, I guess, play in with the rooting depth? So that we're considering all of that profile then plant available, correct?
Your profile sum is a sum of your full profile. So when you look at, and it's just simple math to determine your profile sum. If every single sensor in your profile said 50%, what would the profile sum value be on a 26-inch profile? 13 inches. If we had a 36-inch profile and every single sensor said 50%, then we'd have 18 inches of moisture in 36 inches. So when you're looking at a profile sum, it's just adding up all of the water that all the sensors are sensing. In the case of a root zone sum, that's where you could customize how deep it's summing your water up. Excuse me. Okay, anything else, Ben, that you've seen, or Shelly? Anybody else have any other examples?
Don't see any other questions in the chat.
Okay. Brian, did that help? Do you have any other examples on your side or any other
No,
questions?
that helps. I guess just one dumb question too, if you don't mind. So
Yeah.
when we're above the full, is that considered saturated? So we have 100% of the air, the pockets are full of water, or how's that kind of figured in?
The full point should represent field capacity, which is theoretically less than saturation.
Looks like we actually do have another question that came in.
Because the full point is watching for the pattern that occurs in a profile sum when you hit field capacity. Field capacity meaning the point at which our root activity begins again. In other words, if where's the one that's finally received the most? Probably here. I'm still not 100% convinced that this is even our field capacity because it just picked up right away after that that big rainfall event. But I mean, let's say that we saw something do this and then a sharp decrease again, and then our root activity starts. This water is saturation. Like that water is there. It's not permanently being held by the soil, but this water is. And then it starts, the root activity starts to occur again once you get below that point. So that's the pattern that the auto set points is looking for. Sorry, Ben, what were you saying?
Got a question here. Basically, Christy had a question here saying that her moisture levels have been a little bit less than optimal in the mid and lower levels, and she's wondering how to rebuild those levels without running into issues of leaf wetness going into tasseling.
Increase your base rates, which is sometimes a hard conversation to have with the grower because they'll go, well, I have to water it every 4 days, otherwise it'll die. No, it won't. In other words, if you can make your graph go like this, instead of this, right? We ended up in the same place, right? We applied the same amount of water in both examples. In this example, our leaves stayed wet a lot longer. In this example, we applied the same amount of water. We probably increased our pivot efficiency. So we probably end up saving a little bit of water. The question is in the example where you're applying more water at a time, are you in a soil that can support that? Do you have a do you have topography in your field that will limit your infiltration to where you don't want to have runoff, of course. Those are factors you got to think about. You could mitigate those factors by doing VRI. If there's only certain areas where you have to avoid overwatering, but that in general would be a good strategy for that.
Yeah, that's the hard part, trying to get them to do more at one time, because I told them it's not going past 14 inches, and if you want it to, you're going to have to do more. But they're surprisingly, at first they didn't like that I wasn't telling them to water, but then when I tell them to water more, they don't like that either. So you can't win.
Yeah, and I would go back to that, that report card analogy. If you're trending upward, downward, flat, As long as you're trending flat, you should have a great crop. And even if you're trending downward, as long as you're not crashing, it's going to be just fine. Very good. Thanks for attending, everyone. We will be sending out invites for the next series of webinars. And if you haven't seen the schedule, you should have received it last week. Is that right, Shelly? We sent out a schedule for the whole next 2 or 3 months and each topic. So be on the lookout for those invitations.
Thank you, Nick.
Thank you.